All right. Everybody, welcome to Cassandra Lunch 33. I can't believe we've done 33 of these already. We took a little hiatus. I think the last one was almost last month, December. Last time we covered data operations, common ways to do data operations. Today, we're going to take another item from the backlog of ideas of what we could talk about. And I'm going to use one of my old presentations to talk about some concepts about deploying Cassandra using automation tools such as Ansible and Terraform. There are folks that use Docker and Kubernetes to deploy Cassandra. That's going to be another topic, but this is primarily how real platforms, put systems up. Thanks, Zach Week, for co-organizing and recording the event. Always need some help with this event. We're part of a larger community, Data Community DC, as you can see. What do we cover here? We cover Cassandra and all things related to Cassandra, things that work with Cassandra, things that act like Cassandra. We don't have any new folks on the group today, but we can go ahead and move forward. Group rules, if you have a question, just ask it. We at Anant, we focus on data platforms around Cassandra in Spark and Kafka. DataStax itself is a partner who maintains one of the commercial distributions of Cassandra. GW is a partner that have given us event space. Hopefully they'll give us more. We have some local sponsors, as well as some organizational sponsors. And are there any announcements? I didn't think there were any upcoming events, but we can quickly check. Yeah, we don't have any upcoming events. Except for the weekly workshops and, the weekly workshops that DataStax puts on, and then obviously these Cassandra lunches. These videos are also available online. And a lot of the things that we mention in the Meetup, we save to Cassandra.Link. So you should be able to find pretty much anything we talk about on Cassandra.Link. And if it's not there today, by the next build, which is a nightly build, it'll be there by tomorrow morning at 5 a.m. All right. So a couple of items before we get started related to Cassandra deployment. There are some new features that folks should be aware of. One is that Spark, there's a Spark library that can be used to just read SS tables directly from disk using Spark SQL. This is huge because it means that we can take a snapshot of data from a cluster and read it via Spark and do analytics on it, even take it and put it into another cluster, another live cluster. So it gives us a lot of options around how to deal with SS tables. It's really powerful. And that's also, I think I put it on the Cassandra.Link already. The CASCOP and CAS operator projects are merging, as I think I mentioned before. It continues to move forward. Reaper 2.1 is out, and Cassandra 4 is dropping support for all older OSs, like Ubuntu 7. Like it's like 13 versions too old. Today I actually want to show a deck, but I may be able to show some of our internal code, which again, I'm kind of broken in terms of whether open source or not, because some of it is things that we've taken from elsewhere and worked on and fixed, and then there's other things that are completely new. But at the very least, you should get an idea for where to find the same resources that we found and used to bring these things together. The deck is all available. If you look for, how to build a multi-data center Cassandra cluster in AWS, you'll find it. I'm actually going to cover Ansible and Terraform. There's a bit of Ops Center LCM that I'll talk about, but that's just specific to data stacks. So this deck really goes into the, why do we do manual versus automated? But, basically, no one should be legitimately installing things manually. What do we want? In this particular demonstration, I was showing that you can set up a node with 3 nodes, set up a cluster with 3 nodes, one for data center 1, one for data center 2, and then one for, in this case, Ops Center, which is kind of monitoring software and management software. And then later add 4 more very easily. And then the same amount of effort that it would have taken a human to add 4, you could add 40 more. And if you were to do it manually, like how long would that take, right? So obviously automation is the way to go. The script just shows the recommendation. And by the way, this is wrong. I don't. Oh no, yeah, you could do snapshots and clear snapshots. Stop there. Never mind. This grid basically shows the breakdown of where these automation tools fit. Terraform is really great for automation of the infrastructure. For, let's say, if you're using Cassandra here instead of data stacks in the system operations. And the rest of it, where we see Ansible, in this case, is to set up the system, and then Ops Center has the tooling to install itself and install, well, it has the tooling to install data stacks. You have to install Ops Center. But everything that you see Ops Center doing here, you can use Ansible to do, right? You can use Ansible to do all of these things. So major steps in dealing with Cassandra is obviously the infrastructure, installing the binaries for the very first time, configuring it, and then ongoing kind of configuration if you have to make any changes. And then in maintenance, what we mean is that running, things like backup, restore, doing a restart, and then upgrade itself. So this right here, even if you were just using open source Cassandra, you would still have to do some service operations, right? You would still need to do basic installation, configuration, maintenance, and upgrade, and you have to deal with the system. So even if you were to use even if you were to use Cassandra and didn't have DataStax agent, you still need to do these things. And so Ansible, in my opinion, is the best tool to manage Cassandra. People use Chef and Puppet to do this as well. I just found more examples on the internet for Ansible, and so that's why I picked it up as my de facto, in our company's de facto way of installing and configuring Cassandra and DataStax. Why not use one thing for everything? Technically, we could have used Terraform to even make these things, and some of the code that I'm going to show, you can actually see that. But most cases, you'll have infrastructure already set up that you have to install things into it. So Terraform is useful for creating infrastructure. It can even create Kubernetes infrastructure now, but that's what Terraform is for. People have used Terraform to do things like installing software and configuring it, but I don't really think it's great at that. Ansible has been used to deploy infrastructure, but I think that Terraform has a much better way of doing it. And then finally, in this case, Ops Center is used to do operations at this level, but you don't need to have Ops Center. You can do everything with Ansible itself. So a couple of the repositories that I looked at to, this is an old presentation. So I had seen Terraform and Ansible code before, but this is where I really used to cut my teeth on it. The Rocker Labs Ansible DSC has pretty good reference material to take a look at. It's kind of old, but still really useful to take a look at. And then there's this article on Hacker Noon about how to use Terraform with AWS. Again, it's an older article, but still gets the core concepts across. We'll take a look at these in a second. So when we're creating infrastructure using Terraform, what we do is we have this code that looks like JSON. It's not really JSON. I forget what the actual markup language they call, but it represents a state of the system. Now, a lot of the state of the system, meaning like what is there right now. And so the first thing that we do is we say, Terraform init, and it just goes to the cloud and sees the state of where things are. It's not going to make any changes. And then when you say Terraform plan, it takes whatever changes you have in your code and it says, what do I need to change on the cloud state? And it creates a plan basically. And you don't have to apply that plan. You can just save the output of it somewhere and then apply it later. So an output of a plan step is basically the changes that need to happen to maintain the correct state. So taking the old current state, making any changes, what's going to be the new one. And sometimes and then when you apply the plan, you get outputs. If you've coded it in your Terraform code, it will give you output. So why would you need outputs for this? Well, you want to maybe know, hey, I set up a machine, I want to know the IP address of it, right? Or I set up a cluster with 6 computers, I want to know the internal and external IPs of it. And it comes out like this. I guess this could be considered JSON. Yeah, but it's easy to parse it. And I'll show some code where one of our team members took the output of this and then converted it to Ansible hosts. But there's also provider in Ansible to basically talk to the cluster and get the inventory, right? Depending on whatever tags you have. So that's a little bit more advanced. Terraform, awesome tool. You don't need to have any server. You just run Terraform locally. So you could run Terraform on your computer with Linux or Mac. I've never really tried it on Windows, but I've used it on Linux on Windows, Ubuntu, Windows subsystem for Linux, and it works fine. Basically, that binary is doing all the work, and the only thing it needs to talk to your cloud is credentials, okay? Ansible, on the other hand, does do stuff on the server which you interact with. You don't need to have an Ansible server. You can pay for those things for either Terraform or Ansible, but Ansible, again, it's a binary on your computer. I think it's based on Python, and it takes your code, which is essentially, here's my inventory where I want to do X, Y, Z, and the inventory can also include particular variables. In this case, we've set some variables that we want to replace later on. Or excuse me, in this case, these are the variables that we're going to use in the tasks upcoming. And then you have your playbooks, and you can have a playbook, you can have a role, or you can have a task. In this case, this playbook essentially has everything in one place. It has the host, it has the variables, it has the tasks. Specifically, in this case, it says, go get the code for this project and then restart it using, this command, for example. Or, and this is like a kind of a pseudocode Ansible here. But when we think about a playbook, you can think about a playbook as a collection of tasks, or you can think of it as a collection of roles. What is a role? A role is a collection of tasks. It's kind of hard to describe. Until we see the code, I think you'll get a better understanding. But to put it frankly, like if you have a computer, you have a virtual machine, you can have a role to do the common tasks that you would do on all every computers, secure things, set permissions, etc. Then you could have another role for, let's say, installing Java, right? Or whatever prerequisites for your core technology. Then you can have a role for installing data stacks. So if you have a group of computers called web servers, you're not going to apply that data stacks role, but you may have a group of servers called database or data stack servers, and you can say apply this role to this group of servers, okay? again, benefits of Ansible with DSC or Cassandra. I mean, things that we do even before using Op Center, right, just to prep the machines, to do some of the system changes, to do it across, let's say, 6 computers, got to log into each machine, even with Movax term, you kind of have to, juggle a few things. But you can apply a setting against the machines in about minutes. And Ansible can also be used to run a parallel command across all of the servers at the same time or sequentially, right? So one of the things we do is we collect node tool table stats. Well, basically we go to each machine via SSH, we run the command, we save the output. But with Ansible, you could say, run this command on all the machines and save the output here on that machine. And then you can have another command that basically says, copy that file from there and bring it over to your bastion, or vice versa. You can copy files from your bastion to all of your machines too, right? So example of a playbook, as I mentioned, like a common playbook, right? Confirm credentials. Can we get to this machine can we get to the servers from my Ansible bastion or Usually what we do is we have one computer, like a bastion or like a jump server, and we'll have Terraform and we'll have Ansible installed there, and we'll call that a bastion also. And so the first thing you want to do is to validate, do I have access to all of these computers, right? So after you do the Terraform, create all the machines, you want to check with Ansible, can I actually get to these machines with Ansible via SSH? And that's all Ansible needs to operate on the computer. It needs SSH. And the way it stores state is it has to run those commands, but it keeps some files on that server where it ran the commands, right? Just to know what has been done and what's not been done. Other things like modify system kernel attributes, network memory, file limits, things that actually one of my coworkers and I were struggling with because we don't have control of the server. If we had it as a playbook and we told the super user team, okay, just run this playbook, then it would automatically do it the exact same way on every machine. And in this case, I also had a playbook called Op Center, which it does all the steps that the installation instructions say on how to install Op Center. If it's on the DataStax doc, it can do that. So it's not limited to Op Center. You can have anything that, if you can script it out in the shell, your playbook can be basically a collection of those tasks. So the question is, why wouldn't you just write shell scripts and just run them on every computer? The reason is that if you break it down into these discrete steps and you apply the playbook, Ansible is tracking if that command happened properly, and it stores it as applied, right? And you can force it to reapply it. And some commands are like file copy or file modification or system modification. Some things are to do an additive event. So in that case, it's not only tracking the whole server ecosystem, it can track variables for you in your central Ansible repo. You can have particular variables for a group of servers or for a particular machine, right? Or for a particular role. And to apply that one change, you would update a variable file or an inventory, and you would say apply. If you add new machines with Terraform, you update the inventory and you say apply. And so that's why you use Ansible or a shell script. Because Ansible is essentially executing the shell scripts for you and keeping track of them for you, and it's doing it in an orderly fashion. I'm not going to go into Lifecycle Manager because, that's a different technology which is used to install DataStax. It's really cool, but I want to keep that as a different discussion. Any questions so far before we kind of look at the code? Okay, so let's take a look at Terraform code. And again, you don't have to be a DevOps expert to pick up Terraform. You just have to understand computers And like if you've ever made a computer on Amazon or Google, you can understand Terraform. And then the Racker Labs, oops. All right. So yeah, Terraform available. Oh yeah, great. Available on Windows, pretty much every operating system. Let's see. In this case, they're making a user in AWS, right? And they're giving that user permissions to do things on AWS. If you don't have permissions to do things on AWS, then you can't make stuff with Terraform. It uses your credentials. Now, this is the old way of doing credentials. The newer way is you just log in using the AWS CLI, and it stores it. You don't have to have it like that, although this works just as well. The way you go about it is you have to have a folder per state, meaning you can have a state for dev, test, and prod, but you should have a different folder for each of them, because that's where you basically will keep your state, right? And that's important to note, is that you can think about it as, well, I have the same Terraform setup in dev, test, and prod. Why can't I just have one directory? Well, because your code to set up those environments structurally is different from the state of the system. Because eventually in your Terraform, you will be referring to security group IDs. You will be referring to particular instances to make changes. And they're not going to be the same in dev, test, prod. Okay? So in this case, we set up one directory, we make a file, right? And we say in this region, again, this is a slightly older provider, but don't worry about it. But basically, we're saying, here are my credentials, right? And I want to make a computer. On the same file, I say I want to make an AWS instance. I want to give it a name or a label, basically web. And I want to use this AMI ID. This AMI ID is whatever is on Amazon, whatever the specific Amazon instance is. So here alone, you can imagine, like if you have an AMI for prod and it's slightly different than test, then you'd have a different AMI ID, or maybe not. Maybe you have, you want to use T1 micros in dev, and you want to use, M5 8XL in prod, right? So you can change the instance type. And then any tags that you could set up in AWS console, you can put here. This is useful because if you're managing hundreds of servers, you want to put tags on things so that you can maybe find them later in the console or even through this. Right? You can say, apply this setting to all the servers that have this tag, for example. Okay. Now, I don't really need to go into the, okay, here's what I mentioned earlier. So, after you've got this one file, right? You have your main.tf, you set up your credentials, and you say Terraform in it. And Terraform will go and get whatever provider plugins it needs. It will essentially say, here's what I found. It'll install whatever you need if it's in the public provider repository. And it'll say, hey, everything is set up. And then you run Terraform plan, and it gives you this output. This output is what I mentioned is the state change file. You can use this plan. It's a plan. You can use this plan to apply to the same cluster, right? To the same state group, or you can use it to apply elsewhere. People do that too. They'll plan it, they'll test it in one environment, and they'll take the same exact plan to apply it in another state, like dev, test, prod. Why is it okay to take a plan and apply it in different environments? Because the plan is just a change of the current state. It's not the actual state. In the directory that you make this .tf file, main.tf, it will create a thing called tf state. And the tf state is the expanded version of the state of that particular environment. You can set up variables, and and you can use that variable in your code, right? So you can have even the type of machine, the number of computers, et cetera, in the variables. And that way, the only difference between your dev test prod is a variable, right? Some folks will use branches in the same Git repository for dev test prod with different variables. They'll merge in changes, and then they will take the TF state, and then they will save it back into source control, because the TF state is text file. It's just basically showing how to use variables from the, to do the credentials. So it's kind of modular, right? Here's where, for example, we can take one, region and say, I want to use this AMI in this region, for example, right? What else is interesting here? Yep, we can do things like, hey, I want to run this plan, but I want to replace the variable for X region with this. Okay. And then, I would say set it up on your own and play with it. But ultimately, the output matters, right? After everything is done, I want to know what happened. And in your code, it will, I don't know why they're not showing an output here, but I showed you an example of output earlier. Anything that happens, it will show you that X, Y, Z happened. Before anything happens, it asks you, are you sure you want to do this? And after it does it, it'll say this thing was added, this thing was changed, or this thing was destroyed. Right? In the plan, it says this thing is, we're going to add this, we're going to change, we're going to add one thing, we're going to change nothing, and we're not going to destroy it. And then when you apply, you have to say yes before it does anything. Any questions about Terraform? Okay. Terraform wraps all of the major cloud providers' own internal languages. So AWS has CloudFormation. Azure has something called ARM, Azure Resource Manager. Google has its own thing. DigitalOcean has its own thing. But with I'm trying to show you all of the different providers. There's a lot of providers. This is not the only list. Boy, they really don't want you to know what cloud they're on. Oh, okay. I think I know what's happening. They're setting up this thing called Terraform Registry, which is slightly different way that they're doing things. And it's still kind of annoying the heck out of me that they just don't list all the ones out there. So let's go to the registry, providers, all right? So the main ones, obviously, Amazon, Azure, and Google. Kubernetes is now a first-class provider. So if you have Kubernetes set up, you can use the Kubernetes provider. And then you can go deeper. As you see, they have for Ivan, which is a kind of a managed Cassandra Kafka service. They have, where did it go? Cloud automation. I want to just focus on like the main cloud. Oh yeah, IaaS is it. It's a DigitalOcean, Databricks. I mean, if anybody real uses it, it's here, and the provider system. Yeah, it works with GitLab. So that's Terraform. Right. Let's take a look at Ansible. So Ansible, this is an example. Again, it's a little old, but it demonstrates the core concepts. If you were curious about either Terraform or Ansible in terms of relation with Cassandra, if you just go look here, there's a bunch of stuff for like setting up Terraform on AWS with Cassandra, setting up Cassandra on AWS with Terraform, setting up multi-node. So there's a bunch of examples if you look for just Terraform here. And then you can also look for Ansible and get the same thing. The Racco Labs is one of the ones up here, right? And there's other examples to look into. One notable library is this Pronto, DSC Pronto, which has a combination of Packer, Terraform, and Ansible together. They kind of like made the solution. I don't know if you can replace this with Cassandra, but it's worth a look. Back to Racco Labs. So Racco Labs is a company that, well, Rackspace is a company that took the open source Apache Cassandra and were using it, and that group that was making it there became the group that became DataStax. So historically, Racco Labs is really responsible for making Cassandra usable for the public. Over time, it became DataStax. First it became Reptilo, and then became DataStax. So this code, even though it's 5 years old, it can provision clouds on Rackspace infrastructure, so you can kind of ignore all of this, right? Because that's what we use Terraform for. And then you can see that it's using the playbook to apply some things, right? So let's take a look at Provision Cloud Playbook. And in this case, what it's doing is it's basically setting variables. Let's take a look at the DSC playbook. All right, so what is the DSC playbook doing? It's getting information from somewhere and it's updating the topology locally. Then it's just checking to see if the DSC cluster, if there are any errors, it's kind of doing a validation. Then it's applying the DSC role to all the cluster members. Serial means it's going to do it one at a time. It's not going to gather facts, it's just going to apply these changes. And it's setting particular variables for DSC. Okay, and we'll look at this in a second. After that, it's applying the op center role on only the op center group. And there's some pre-tasks, and then there's post-tasks. And then this is the role. So if you have a role, you want to do something right before it and right after, you can put that in here as well. Point to note here is that these are wrappers to other modules that Ansible has, right? So you can have a module like add user or add group. Why would you do that versus having a shell script that you put in here? Because as operating systems change, Ansible is upgrading and constantly being the latest version. It will make sure that whatever your Ansible commands are, it will get applied to that operating system. Okay. There's also modules that like deal with packages, and some people use Red Hat and some people use Debian. So in that case, it can detect which package manager you're using. And in fact, I have an example where it kind of does both. It detects which one it is and it uses Debian and uses RPM. But the point I'm making is that this wrapping of the underlying things makes it easier to continue maintaining it going forward. You don't have to deal with the shell version. You don't have to deal with the operating system version. And then finally here, it applies the DataStax agent role, and it does a bit of cleanup. So this is the whole playbook. Let's take a look at the roles. So there's a common role, there's a DSC role, there's a data stack agent role, there's an offsetter role. We're just focused on Cassandra. So let's focus on the common role, and then we're going to look at DSC. So common is what we want to do on every single server, okay? So if I look at the tasks, you're getting the OS versions, we're installing, this is the enterprise, I think it's RPM, so it's Red Hat basically, right? When the OS family is Red Hat, do this. When it's Debian, do this, right? That's allows you to kind of save time depending on which operating system. And then here, all the things we do to set up, at the system level on Cassandra and DataStax, it's doing it for us. So sysctl changes, making sure NTP is started, configuring no file limits, which we always run into, nproc limits, right? All the things that we would do on every machine that runs Cassandra, we just have it as a playbook here. And again, depending on which OS family that it's found out, it does either apt commands or RPM commands, YUM commands. So let's say that our servers are all up to date with the common playbook. Next thing we want to do is to install, let's say, DSC or Cassandra on each one. So there's a config, which basically says that, when I apply configuration, notify the restart DSC command. So anytime these things actually get executed, which is taking the template and applying the variables to it, restart DSC. Okay, and then the main, basically we have is install YUM packages if it's Red Hat, or install APT packages if it's Debian. Flush the handlers, and then go ahead and run the configuration YAML, and then afterwards check to see that DSC has started. So this is going to keep checking to see if it started before going to the next server. Right? If we have a serial that says go to each machine one by one, all this will happen on one computer, and then it'll go to the next one. Only after the node is up. Let's quickly take a look at so the DataStax agent one is going to be very, very simple. Install the agent, updates essentially some information that you need to make sure that each address.yaml is updated properly, and go ahead and restart the DataStax agent once that happens. So where does it get all that information, right? Where's the config information? Well, that's basically in your variables, right? So you have your cluster information, your password for DataStax repository, Ops Center configuration, right? Cloud configuration, topology, here's my data center. I just want Cassandra on here. Okay, now this is one way to do Ansible. Just one way to do Ansible. There are different ways to do Ansible. Let's see if they still keep their Cassandra Ansible here. Yeah, good, they do. Again, it's a little old, but slightly different because with Cassandra, normally we would install using a tarball installation. So for example, if I look at, they really didn't do this properly. Yeah, I wouldn't recommend looking at this. Let's take a look at another one. Let's look at this one. This is slightly better because it has support for backup. And the one that I really like is Yabin. Yabin Meng had done one for DSE. He had open sourced it. Let's see. Sure. Maybe I didn't save it in here. Yeah, there we go. He has actually a Terraform one as well. I've worked with, and yeah, he keeps it updated. I've worked with Yabin on a couple of projects. I think he's still at DataStax. Let me make sure that this is in. Make sure that goes into our repository. Yeah, it's updated for upgraded versions. So his structure is similar to the other Rack or Labs one, right? So we have install, uninstall, upgrade as a playbook. We have different roles. He has different roles for installing binaries, updating the binaries, updating configs. There's a common playbook, right? And then the variables are all here, right? If we're doing an upgrade, major version, minor version upgrade, other variables that get set inside Cassandra YAML, okay? And then actually, while we're at it, we'll take a look at his Terraform code. So his Terraform code is, hey, look at that. He's using Terraform and Ansible. Good for him. Let me save this too. I think I made it already. Yeah, it's already saved. Cassandra on it. So basically, if you get this repository, you're good. So what is happening? First, you run Terraform. You make your machines. Then you get the inventory, which is you take the output of Terraform, and he basically has a shell command to then create an inventory for Ansible. Ansible needs an inventory of servers to do its job. If it doesn't have computers to do its job, then it can't really work. It looks a little more complicated than I thought, but it creates the inventory. Then it says, go ahead and run Ansible. So, do the operating system kernel parameter changes, set up DSE, set up Op Center. That's it. So if you have this stuff in your environment, you basically would say run Terraform, create the inventory, and then run Ansible.sh, and everything would happen in one by one. Let's take a look at this Terraform script. So he's got an EC2, kind of talks about his, basically what he wants to create here. You see main.tf. Yeah, so main.tf is just kind of like the high level credentials, security group setup, variable setup, right? All the different variables for the servers. And then once the servers are created, he has an inventory that gets created here, but these are kind of the common variables. We saw it in his other repository. And then we have DSE application install, right? So install the package, install things like JDK, do these roles, common install bin, update configuration, start the DSE nodes one by one, start the DSE seed nodes one by one, and then start the non-seed nodes one by one, and then check to make sure it's up and running and that we have a version number, right? If we take a look at the roles, how do we install binaries? In this case, he's opting for APT, so this is based on Debian. And you can make one for RPM if you want, but in this case, it's just for Debian. Cool. As we come up to kind of the top of the hour here, I'm going to go ahead and even though I've saved it into Cassandra.Link, I'm going to put this into the workflowy we didn't get to the other stuff here, but it's okay. Yeah, this one. And then this one as well. Cool. And I will stop sharing. So folks, any questions? I know there's a lot to absorb here. It's kind of a brain dump of the two most common technologies in DevOps around Cassandra. Now, so I'll just speak at once. Okay. All right. Yeah, Obi, I thought you had a question. You had a question?
Oh, yeah, I was still trying to put it into words a little bit, I guess, but like the granularity of what Terraform and Ansible do under the hood versus having something like the DSC Docker image. Like what are the pros and cons of the different approaches?
Sure. So it's a really good question. So the thing about Docker, so Docker and Ansible and Terraform are not mutually exclusive. And here's why. You still need machines, right? So you say, I want 5 virtual machines. Then you can go to those machines and run Docker. And you have your Docker file with all your configuration. That's one way to do it. Right? Go to each machine and run Docker, run this, and this is my configuration. So in that, you would have potentially all of your config files on your host folder, and the rest of it is just the binary that's in the image. So it's reading the configuration from your host volume, and it's applying them to the thing. So you have all the granularity that you want, hopefully, right? Once it's up and running on Docker, if it has SSH access, you can run the same kind of Ansible start, stop, restart things. You can even install things if you wanted to, because it's just another kind of like a container that you can run commands on, right? But the thing that Ansible is doing is it's granularizing and automating running commands for you, not just updating configuration. Versus Docker, you kind of have an image of what needs to happen when it first comes up. And you automate what runs at the very, very beginning. Okay? Does that make sense?
Yeah. I was just wondering about like inside of the Terraform and Ansible scripts, it looked like it was bringing up the DataStax instance like manually inside of the commands rather than like making the machines with Terraform and then putting the Docker image on them.
Yeah. Well, you can make an AMI, right? You can make an AMI or whatever image, and tell Terraform, just start this one computer for me using the same image, or start 5 computers for me using the same image. So that would be very similar to Docker, because you have like a pre-built image and you're saying, just go ahead and start it. And so some people do that, but and there's ways to kind of automate the creation of those images using configurations, like it's a configuration tool called Packer. Packer is from the same company that I think makes Terraform. But Packer will take a config file and it can make an AMI for you. So that's another way to do it. So why would you do that versus Ansible? Again, Ansible is not mutually exclusive. You may have a Packer image with everything installed, and then you have you've created a whole cluster using Terraform, but then you have to go configure them to talk to each other, for example. You would use potentially Ansible. You might be able to kind of rig Terraform to do it for you, or you have to do a rolling restart. So in that case, Terraform can't help you do the rolling restart. In that case, Docker can't help you to do the rolling restart. I mean, may be able to. I'm not up to date on what Docker Compose can do in terms of like cycling containers, for example. But pretty much, you'd have to go to Kubernetes to have things like that happen for you. But that's where Ansible is just like, it's a way to run shell commands for you, and it organizes it, and it keeps the state for what has been run and what's not been run. So there's a little bit of overlap across these technologies, but I would say Ansible and Terraform and Docker are in slightly different worlds. They can work together.